Previously, we covered the core foundations. Now in Part 4, we tackle what you actually see when watching a rocket launch. Part 4. The Orbital Dispatch Script. In our last episode, we uncovered why those ethereal jellyfish clouds bloom after stage separation. But there's another visual phenomenon that happens in the blink of an eye, literally. What causes that brilliant flash of light when rocket engines suddenly cut off? That's what we're exploring today. I'm here with Orbital Dispatch, and this is part 4 of our series on what you actually see when watching a rocket launch. We've covered the flame patterns, exhaust plumes, and separation clouds. Now, let's talk about one of the most dramatic, yet fleeting moments in any launch sequence. The chemistry behind the flash. When rocket engines shut down, they don't simply stop burning like blowing out a candle. Inside the combustion chamber, there's still unburnt fuel mixed with residual oxygen from the oxidizer. When the main combustion process ends, this leftover mixture ignites all at once, creating what engineers call an afterburn flash. The intensity depends entirely on the engine type and fuel combination. Liquid oxygen and kerosene engines, like those on the Falcon 9, produce a particularly bright orange flash. Hydrogen-fueled engines create a more subtle blue-white burst that's harder to spot during daylight launches. Why the flash looks different. The flash isn't just about chemistry, it's about physics and atmosphere too. At high altitude, where most engine cutoffs occur, the thinner atmosphere allows the light to appear more intense and sharp-edged. During night launches, this makes the flash clearly visible even to viewers hundreds of kilometers away. But during day launches, atmospheric conditions play a crucial role in visibility. Water vapor, dust, and even pollution can scatter the light, making the flash appear diffused or sometimes barely noticeable to ground observers. The angle matters too. If you're watching from directly downrange of the rocket's trajectory, you'll see the flash head-on. From the side, it appears as a brief brightening of the entire engine bay. Reading the mission timeline. Here's why understanding this flash matters for launch watchers. It's one of the most reliable visual indicators of mission milestones, especially when you can't hear the commentary clearly. First stage engine cutoff typically happens around 2.5 minutes into flight for most missions. When you see that flash, you know the first stage has completed its job and separation is imminent. For single-stage missions or upper-stage burns, the flash signals successful completion of that phase. Experienced launch watchers often use this visual cue to anticipate what's coming next, usually stage separation within seconds, followed by those jellyfish clouds we discussed last time. The technical reality. Now it's worth noting that not every engine cutoff produces a visible flash. Some newer engines are designed with more complete fuel consumption, leaving less residual mixture to create the afterburn. And some cutoffs happen so far downrange or at such high altitude that atmospheric conditions make the flash impossible to see from launch viewing areas. But when conditions align, clear skies, good viewing angle, and the right engine type, that split-second flash becomes one of the most satisfying moments to catch during a launch. What this means for you. The next time you're watching a launch, pay attention to those brief moments when the rocket's acceleration suddenly changes, or when the exhaust plume shifts character. Often, you'll spot the flash just before mission control calls out the engine cutoff. It's a perfect example of how understanding the science enhances the experience. You're not just watching a rocket, you're witnessing the precise choreography of combustion, chemistry, and physics playing out in real time. Next episode, Part 5 explores the next key question in our launch viewing series. If you found this breakdown useful, subscribe for more grounded explanations of what's actually happening during these incredible machines' journeys to space. That is Part 4 of what you actually see when watching a rocket launch. In Part 5, we explore the next key question. Subscribe so you do not miss it.